All right. Hey, welcome everybody. Welcome to the last special event we have of the Next Big Thing, the TALX series. We have a great series of speakers lined up here for you to wrap up the day. Quick announcement at the tail end of this, we will have a social. It's just going to be right out the doors and out here in the lobby and then moving into the next room. So be sure to grab a ticket that gets you into that. So the next big thing, this is culminating about a year's worth of engagements where we've been, for a metaphor here, we've been picking, pruning, and fertilizing, a young plant. And so, we're trying to find those ideas that are right on that cusp of being ready for utilization, but we need to understand it more. We need to feed it some information, engage the community to figure out how we can bring great utility to the military community for training purposes. So that's what the next big thing is doing. And we're going to be doing that again next year, looking at for the next technology, what is the next big thing that's coming in. So for this year, it was the metaverse, and specifically the military metaverse. And so what is the military metaverse? It's, well, let's start with what is the metaverse, and that's what we've been leveraging. And so I'm sorry, let me go back before I jump into this. I failed to thank our sponsors. So we could not do this room and this kind of venue without the sponsors as well as having the socials. So if y'all can give a big round of applause to the sponsors. And so this really is a special kind of event, and we'll be continuing to do this throughout the years with ITSEC. Okay, so the metaverse, and specifically on let's call it on the commercial side, the metaverse. I like to think of that as its presence at scale. And what I mean by that, and if you think about some of the trends, I know a lot of people talk about meta, and that is a bad thing necessarily for the metaverse, but maybe not necessarily so from a social perspective. It's at scale. There's lots of people. They're collaborating, and they're doing it at scale. But it comes short, in my opinion. So what's presence, the immersive nature of the metaverse types environments and the realism we can create. And so when you bring this presence at scale, that in my mind is how I like to think of the metaverse. Now let's add to that, the military metaverse aspect of it. So what does the military bring? What has the military been doing very well? And what they do is add that context. And the military for years has been looking at context, the operational environment, the realism, the complexity of interactions. And they've been taking on that challenge for years. So now blend that all together, and you're creating a very powerful capability for military training, that we've coined the military metaverse. We will hear about that today from our speakers. We've got speakers talking about geospatial data and information, and that's helping provide that context, and as well as that information too has been used very much on the civilian side, and also very much on the military side. So that's going to help bring that context. We're going to hear about standards, open standards, and why is that important in both the commercial side and the military. We're going to hear about the complexity and scale in this realistic environment. And then we're going to wrap it up with a military context of large-scale combat operations and helping us understand how this can all pull together for that. So I'm really looking forward to this. We got a great panel, and our first speaker that's going to come up, oh, by the way, too, in our format, it's talk style, just like TED Talks. And if we have time, they'll do a Q&A, but the idea is I want to have them have maximum time to give their perspective. And then at the end, at the social, feel free to come up and engage them. But if there's a few moments here, we'll do Q&A here at the end of this. So I'd like to introduce Michael Putz. He's the co-founder and CEO of Black Shark AI. Really happy to have you up here, sir. Looking forward to your comments.
Thank you, Bob. Good afternoon. It's a pleasure being here today in front of you, and thank you, Bob, for having me. It's been a while ago when Bob actually asked me to come up here and show you a couple of examples and use cases, detailing what technology originating from video games, paired and mixed with some clever usage of AI, can actually help in driving change and innovation in the space of people here operating like the military metaverse. And okay, so this is working. So My name is Michael Woods. I'm co-founder and CEO of blackshark.ai, and we are a startup actually working on a 3D digital replica of the planet. And you might know us from the Microsoft Flight Simulator. We are the team who built the 3D world of this award-winning product from Microsoft. And it was about in 2016 when I was heading up a video game studio back then, which focused on solving tough challenges, technical challenges for large-scale video games productions. And back then in 2016, Microsoft Xbox Game Studios, being in the planning phase of their upcoming flight simulator, they had this vision to use and utilize their own Bing Maps imagery set as a backdrop for the simulator. And they approached us if we have an idea how we can help them to turn this aerial and satellite imagery, like 2D flat imagery, into actual 3D, like extruding buildings, extruding trees, vegetation, road, mostly everything. And us being rather pragmatic game developers, we took a rather pragmatic approach, look and identify every single rooftop in this imagery on a global scale, turn it into 3D, look and identify to every single tree and bush in this image set, turn it into 3D, and job done. That's a rather simplified description, but actually this is how we tackled it. And now, fast forwarding 2 to 3 years in time, we had a first prototype running who could digest the entire landmass of our planet in less than 3 days and outputting more than 1.5 billion buildings and more than 30 million square kilometers of vegetation, all in 3D. And this innovation made people like Microsoft CEO Satya Nadella calling us and asking, how the heck did you solve this fundamental challenge nobody solved before? And you need to know, like a Google Earth or Google Maps or Apple Maps, they have like about 10 to 12% 3D coverage of our planet. And we had been the very first managing to turn the entire planet into 3D. And at this point in time, it became clear to me that the technology we developed for this video game has applications and opportunities way beyond the traditional gaming space. And so we took the 30 people who worked on the Microsoft Flight Simulator project out of the gaming studio and wrapped a new entity around them, which became Blackshark. So this is our story, it's the story of Blackshark. And now let me show you a couple of use cases giving more and more insight how we did this. First one, this is an actual operational use case from a client who is in large-scale change detection. This is an area of about 12,000 square kilometers, featuring about 60,000 buildings. And this client, using a semi-automated approach with labeling experts and analytics people, mixed with some technology, and it takes them more than 3 weeks to do a full change detection run to identify buildings which went away, buildings which got built, buildings which changed their height. And sitting together with them and applying our algorithms on this imagery, this is a sub 5 centimeter drone sensor. And actually we managed to bring down this from 3 weeks to 10 hours of processing time. And this speaks about the large-scale detection capabilities our technology is offering. And now, as a next step, using these previous results from large-scale change detection, identify a building, roads, infrastructure, this is another example of a client in the civil commercial space. It's a rather large North American retailer working on the future of drone delivery. And for them, we are reconstructing 3D backyards of single-family residential homes. And they are using these 3D synthetic environments to verify and validate the sensors of their delivery drones in this synthetic environment to detect edge cases. Now imagine the drone approaching in this virtual backyard and getting blindfolded by an unlucky combination of reflections from the pool or the solar panels in this scene. The drone cannot land, needs to abort its approach. And the beauty of our technology, this is not manually done, this is all fully automated. So we know the mathematical context of this scene, and with a single button press, we can permutate, for example, more than 10,000 similar but not same not same scenes like that, helping the customer to radically shortcut their time to market by able to test at large scale for those edge cases. And now let me show you a real world problem for this particular customer, which all the simulation and all the synthetic environment actually could not help for. So those are real world problems for drone delivery. And after experience that, the client came back to us asking if we can do synthetic dogs for them. But that's a level of verticalization on top of our horizontal solution we don't provide as a company. But it was eager and interesting to learn. So coming next, you might wonder how we solve these challenges. So now you can see here, and scene, it's Seattle in Washington. This is a Vexcel 7.5 centimeter sensor. And this 2D aerial imageries are mapped on a DEM. And in the first pass, we are running our algos for large scale detection on top of it, giving us, in this example, building footprints. Then as a next step, we use AI to classify those buildings and extrude the heights of it. Depending on the matter of input, it's more or less accurate. The more input data we have, like multi-view points, stereoscopic or DSM, it becomes better. If you just have flat 2D, the AI also helps a lot. And then as a last processing step, we apply a synthetic skin on those buildings. And now let me explain on an example how we classify a building. Imagine we identify a rather large rooftop, which is in dark colors. This already gives us a first hint, because a black rooftop mostly is a flat rooftop. Hinged or gabled ones have mostly different colors. But we feed this information of the rooftop color in the AI. But we also look at other parameters, like the population density in the part where this building is, the part of the world where the building is located. Its orientation to the next nearby road or street, or like examining the examination of the roof furniture, as we call it, how many AC units, how many satellite dishes are on those rooftops, and we all are feeding this in our AI, and as a result we are getting what we call a well-educated guess of what type of building this might be. And to our own surprise, in the very first prototypes of this technology, we had an accuracy rate of more than 85%, meanwhile we are in the 90s. And next question is how we can detect like rooftops. And here we developed our own tool. It's called live labeling. And here you can see a split screen view of an analyst sitting in front of this tool, and with a sparse labeling, he uses two colors. Green, the positive one, means this is a rooftop. Cyan, the other one, helps the machine to understand this is not a rooftop. And in the split screen, on the right-hand side, you see a near real-time output of the classification from the deep neural network. What now the machine thinks is a rooftop. The same for planes. Everyone of us here in this audience can use this tool to add new feature detection classes in a very rapid scale, like couple hours is a realistic value for that. And here's like a road network detection. And also the right-hand side gives you an idea with the color gradient how certain, how sure, how uncertain the machine is, and where it might need help with further clarification using the two-color scheme. And we developed this because of budget constraints for the flight simulator from Microsoft. We only had 2 data labelers to classify the entire planet. So the only way was to use technology to solve this. And now, let me show you when all those 3 steps, like the live labeling, the detection, and the reconstruction, are coming together, and what the output could be. This is presented in Unreal Engine 5. And let me take you to Europe, to Italy. was one of the examples, and this, in our vision, is like to have a near real-time updated database of every single object, static or dynamic, on the surface of the planet. Initially, we use optical imagery, satellite, planes, drones, but as a next step, we're going to add SAR, we're going to add hyperspectral for material classification, and maybe like mobile data for identifying crowds of people. So this is like a never-ending ongoing process, feeding in more information in our platform in order to offer, as the ultimate vision, a Google search equivalent of the surface of our planet. So all I've shown you is there's no smoke and mirror, this is real. And if you want to see this yourself or try it out yourself, visit us at our booth, blackshark.ai, and happy to show you in real time. Thank you.
That's really good. All right, thanks, Michael. That was a really good perspective of how geospatial information is adding a very critical piece to this, representing the realistic world within this military metaverse. Our next speaker is going to be Dr. Nadine Alema. She's the CEO and president of the Open Geospatial Consortium. So please welcome Dr. Alema.
Thank you very much. Can you hear me? Yes? All right. So thank you, Bob, and team Black Shark and Probable for the invitation to be here. Those lights are very bright. So I have only a couple of slides for you, and the first one is my inspiration. So I'm going to leave you today with 3 keywords. Right, so at the end, if you get all 3 keywords, you win a drink ticket for the reception, and everybody's happy. And maybe I will start with, anybody here has kids? All right. Anybody has kids who are borderline video game addicts? So I have 2 boys, ages 10 and 14, so this is my 10-year-old. He's Minecraft. He's, PS5, he's Roblox. So here's a little story. He's been working on Roblox, and he set up this store to create these skins, right, that they use in the game. And he was sort of selling them for $5. And I was like, I'm on the fence, I don't know, right? He's 10 years old. Until I went to the SIGGRAPH conference in Vancouver, which was back in August. It was organized by Epic Games and Cesium. So we had a whole day on the metaverse. And we had Neil Stephenson there, the author who coined the term metaverse. And as part of the panel, the chief scientist from Roblox stands up, and he shows the example of this 13-year-old who made millions of dollars last year selling skins and stuff on Roblox. I rush home, I sit down with my son, I was like, I don't know, can we be millionaires here? It's like, and he looks at me and he's like, oh, Mom, you don't understand anything. Which is, if you have kids, they say this all the time. And I said, why? He's like, you don't understand, Mom. As soon as I do these skins and I put them on my store, these bots come in, start to copy my skins, and start to replicate them everywhere. And that's why for the last months I've been telling you NFTs, NFTs, NFTs. And I was like, okay, my son explained to me NFTs better than anybody in my professional circle, right? I got it, it was practical. And I think my main message with this is, when we talk about these new concepts of the metaverse, right, or anything digital transformation, to actually keep an eye on this younger generation, because they're living and breathing in the digital world. They're almost, I call them metaverse ready. Whether it's good or bad, I don't know, right? But we can learn, and we can listen, and we can just get a lot just watching them. So that was, that was not one of my 3 lessons today. That was a bonus, buy 3, get 1 free. So that was the freebie. So back to my slide here. So this is my son on the PS5, and his favorite game is Spider-Man. And when I watch him play Spider-Man, you know, they cruise and they swing around New York City. And all I can think about is we in the geospatial community have the real stuff. Like we have the real Spider-Man. And I think to myself, I am the CEO and president of the Open Geospatial Consortium. So I'm running this global consortium that houses the best of the best experts in geospatial, right? Those experts that know complex data, big data, data from space, from sensors. They know how to relate anything to space, to location, to time. And if I think we have the governments of the world, from the NGA and the Army Geospatial Center to the NASAs and the ESAs, but we also have industry at the same time doing amazing things. And I'm talking not just about, you know, Google, Microsoft, AWS, Apple, you know, all the big names, but also, you know, Black Shark. We have CAE as members. Many people on the show, on the exhibit floor, are OGC members. And when I think about it, it's like we do so much in geospatial that's just applicable right here. It's just from Michael's example, just extracting features from space or from any remotely sensed you know, data source. We have the LiDAR, we have the sensors, we call them connected systems because we really don't care. We have the 3D tiling, 3D data streaming. We have all of that in geospatial. And what we also have on top of everything are the models for the things. We have city models, we have indoor modeling and mapping and navigation, and we even have in our community, you know, the equipment that surveys essentially the street and can get you maps of the underground infrastructure. We have all of that, so it's really, really amazing. And it's all the power of geospatial. So here I am. I kicked off our Open Geospatial Consortium member meeting in Singapore. That's a month ago in October. And this is not a fancy video, but this was my own experience in the metaverse. So I kicked off our Geospatial for the Metaverse working group meeting in this case, Hexagon's digital reality platform. And there are many things that are cool, I think, about this. One of them is, I don't know if you can tell, but this is actually me walking around. It's not my avatar, so it was me walking around. And the best part is everything is actually a feature. That's the power of geospatial, right? And the even better thing is I was not in a game. I was not in a video environment. I was in a geospatial environment, which means all the analytics and the detection, I was like there, which was amazing. Again, that's the power of geospatial right there. And that's the keyword, the first keyword I want to leave you with, geospatial. So I go around and I tell people that the metaverse is geospatial. Yes, and we even put it in writing in a blog that I encourage you to check out, because the geospatial community is doing so much. I feel like I stand in these, you know, settings trying to offer everything that geospatial has to build, you know, a sustainable, open metaverse environment, whether it's commercial or military. And I feel like we're offering the tools, we're offering the software, we're offering the data, but most importantly, I think we're offering the talent. We're offering years and years of experience to this metaverse, right? That's why it's a reality. And I like that in our circles, we call it, we're blurring the lines between virtual and reality. We're doing that. And you saw it. I mean, Mike did it, even with that dog, which was amazing. So keyword number one is geospatial. I hope you can sense how excited I am about geospatial, because I also claim that there's never been a better time to be in geospatial. We're living in a world where you can get geospatial data easier than ever. I mean, I worked at NASA, so I go back to Earth observation, and we used to have the space agencies and Maxar. Now we have a whole portfolio of sources to pick from. You have the drone, you have the balloons, zettabytes, right? We're actually talking zettabytes now. We throw it as if it's, zettabytes here. It's amazing. Same thing when we talk about the Internet of Things. There are too many studies to quote one, but again, when we live, I love this, somebody said it last week, we live in this world of datafication. Everything you touch is becoming data that's related to you, to space, to time, to location. And we are harvesting and we can process this information and simulate and so on. So it's just amazing, amazing times. That's the good news. Now, the flip side of that is if we're gonna pick any problem we need to solve, or if we're gonna pick any environment we need to build, if we wanna do the metaverse, whether again, any metaverse, regardless of how you wanna define it, I like to think about it as, fully immersive 4D dynamic environment. What are we gonna do? What are we gonna need? It's data integration at the end of the day, right? So we tend to say magic happens when data meets data, and it's very, very true. The value of any data source is just, amplified when it's combined to other data sources. The problem is when we're standing here drowning with data, with information, it becomes really, really hard to mix and match, to find out which data you need to use. What's the data quality? What's the provenance? What's the fit for use? How can I get it? What's the format? I can go on. So I'm here claiming that you'll never be able to build a sustainable environment like the metaverse without, what's the second keyword? No cheating. Standards, yes? You're never gonna be able to build something this big, this really not quite defined, this dynamic environment changing where you wanna put, when you wanna add new data sources, whether we're from like real-time sensors, or you wanna bring in multiple digital twins to build something bigger. You're not gonna be able to do that without standards. So that's my second keyword, so geospatial and standards. I think standards are the glue. I'm pretty sure you're thinking, oh, she's so biased because the Open Geospatial Consortium, that's what they do. And yes, so we're doing, I bet you know more about OGC than you think you do. If you've heard of KML or GeoTIFF or CDB or the Web Map Server, and I can, go on down the list, 3D tiles, they're all OGC standards. If you've used Stack, this is all, geospatial and standards. So yes, I am very biased, but I'm not crazy. Have you heard of the Metaverse Standards Forum? Anybody? So if not, definitely, Google it afterwards. So this is a forum that was stood up in 2022, so this year. And it's a forum, it's a standards forum. It's not a new standards organization. It's literally just a forum so that we can have this conversation about what do we need to standardize in order to have a viable, open metaverse environment that people can build on top of. All right? So this Metaverse Standards Forum started with 37 founding organizations. And you can look them up. So I'm happy to say OGC was one of them, the Kronos Foundation, Microsoft, Sony, Epic Game, Unity, Microsoft, IKEA. I mean, there's 37, it's a bunch of, interesting organizations because it's literally from everything and everywhere. The amazing thing about this standards forum for the metaverse is that within 2 months, it went from 37 organizations to 1,500 organizations, right? That was the last count in October, so I really didn't check last night, but 1,500 plus. And that's how I know I'm not crazy. I'm not crazy. There are at least 1,500 organizations worldwide. Some of them are consortiums, so it's actually really much bigger, that believe that standards are critical to actually building this idea of metaverse as a foundation for so many other things, right? For training and simulation, or for climate change. Where's Jen Arnold, one of our heroes here from NVIDIA. So we have a large group all over the world very interested in building something that's sustainable, that can mix and match, again, data sources without locking in anybody. So geospatial check, standards check. It's all very exciting. It's all great. We are all happy. Yes? No. I'm sorry. So here's the issue. It's all really great. And I walk down, this conference exhibit hall and other conference exhibit halls, and it's one amazing demo after the next, and digital twins after digital twins, and so many newcomers, and traditional providers and system integrators. And I feel that we're missing, I'm missing, at least when I look at this ecosystem that's bubbling up, a more, I would say, sustainable or consistent investment, right, in the standardization as a foundation to actually allow this ecosystem to work together and to grow bigger than the ad hoc partnerships that are happening on the exhibit floor. So my third keyword is actually engage. So when we talk about the metaverse, and it's a new thing, and it needs standards, these standards, some of them do not exist right now. You have to actually roll up your sleeves and help us create the standards for this foundation, for this infrastructure, right? So I would say don't go home and just Google and follow the Metaverse Standards Forum or the Open Geospatial Consortium or the Cronus Foundation, right? Join, roll up your sleeves, test, develop, collaborate, innovate together. Because at the end of the day, the metaverse, at least to us, it's not the end goal, right? The end goal is not to build a metaverse or multi or whatever that is. It's just a means to an end, right? It's a means to have some collective problem solving at scale and quickly. And when I look at my watch and we talk about quickly, the example that pops up in my head is disaster response, right? Climate change. So how amazing if we can actually incorporate, all these silos of science, right? So the hydrology and the weather. I mean, we have weather data and met data and forecast and ocean data. That's all geospatial, but they're in silos. But the metaverse allows us, as this idea of a 4D fully immersive environment, to actually bring them together, and maybe we can then accelerate our understanding of climate resilience and adaptation and so on. And once again, I go back to the exhibits downstairs, and we're seeing them simulate not just spaces, but also people and behavior. So we can definitely do that. So I would leave you then with these three keywords, right? So geospatial has a lot to offer. There's no need for anybody to reinvent the wheel. So let's get all on the same bus. Standards are not boring. They're essential. We need them as a foundation for this new environment that we're all building together if we want to do it in a sustainable way. And bringing, again, if you think about the Metaverse Standards Forum and the 1,500 organizations, maybe 1,000 of them I've never heard of, because they're like, real estate and car agents and NFT people, right? There's no way we can bring all this together and have the metaverse reach its full potential without a baseline, a foundation of standards. And the last one is, it's not magic as much as we like it to be. It's an investment. It's a deliberate, conscious investment in collaboration and in standardization. So did you get these three keywords? Yes? Your drink ticket depends on it. Yes? All right. So my work here is done. Thank you so much. Appreciate it. Thanks again. Thank you.
That was a great message. You know, it got me thinking of the previous session where throughout the day about not one company builds the metaverse. And I think what you were discussing about standards is so important to that message of it's going to take this entire community and ecosystem to really help realize this military metaverse. So thank you very much, Dr. Alamo, for your message. It's very relevant. All right, our next speaker is going to be talking to us about scale, complexity, and how we're pulling this from a commercial metaverse company. And so our next speaker is Rob Soley. He's the Director of Research Partnerships at my parent company, Improbable Defense. So please welcome Rob to the stage.
Okay. Well, hi everybody. They say you should never start a presentation with an apology, but I am replacing Rob Whitehead, and I think they looked at who was called Rob in the organization and who had a white head, and they sent me. So I am Rob Soley. I am the Director of Research Partnerships at Improbable Defense, and I'm going to talk to you about communication and how that will enable collaboration in the metaverse, the military applications of the metaverse. So we've heard a lot of definitions and confusion about definitions actually over the series of events that we've talked about the metaverse in the last few days. And I don't think there is a single clear definition. But whatever it is going to hit us. The metaverse is coming. And projections at the moment of about 2.8% of global GDP is likely to be targeted, actually spent in the metaverse in the next 10 years. That's $3 trillion. That's going to happen in the commercial world, and we need to adopt it and adapt to it and embrace it in the military environment. So it's coming. I'm going to tell you what I think it is, but I might be wrong. And I'm going to give an example now of how the same kind of thing happened maybe 25 years ago when the internet was coming around. So there's a great story about a young guy called Bill Gates who appeared on the David Letterman show in 1995. And he was trying to explain what David Letterman called this internet thing. And he tried really hard. He talked about the technical things that it could allow you to do. He said, well, we're going to be able to store information electronically, and we're going to be able to publish that information. But to David Letterman, this didn't land. And my contention is that he wasn't talking about what people would do with it. He wasn't talking about what it would mean to people. So instead, he was talking about the technicalities and what practically might be done, how the technologies might work. At the end of their interview, David Letterman, having asked him, well, I don't see how this works, does it ring a bell? That was his attempt at trying to understand what practical use the internet could have. He concluded that there was clearly, sadly, no money in the internet and computing. And we know who was right, actually, after all these years. Bill Gates obviously was right. But I think we're in a similar position today. There's a lot of talk about the metaverse, but a lot of that talk is about the technology rather than about the impact that that technology will have. So I'll have a go at telling you why I think the metaverse is going to change things. Because for me, the big thing that it will do is bring people together. It will enable us to come together with a sense of community, communion even, but also it will enable us to collaborate, and it will enable us to develop trust and familiarity at scale. Trust and familiarity at scale. So what do I mean by that is it's going to help many people to learn how to work together through collaboration. At the moment, that's still quite small. In most cases, you don't see thousands of people engaging together. So that's where I think the metaverse will take us. And why is that the bit that I think is going to land? Because it's all about communication, how we as a species, how we actually like to talk to people. I mean, why are we all here? Okay, we're here in person because actually engaging with people in a meaningful way on a one-to-one basis or a many-to-many basis is actually fun. It's interesting. It's productive. It's fruitful. And it has some kind of purpose to us. So the metaverse, I think, will lead us into a similar kind of way of engaging with people. But if you look back over time, that's how people used to talk, face-to-face, around a campfire, let's say. And then over time, as communities grew bigger, people developed technologies like smoke signals, I guess, or the post service. Eventually they got the telegram, and then they got email, and then they got social media and WhatsApp. But all of those systems are asynchronous communication systems. So you send a message, you tell everyone what you want them to hear. They may not pick it up, they may not hear it. They may reply, and if they do, it'll probably take a while. And when it does come, you might not see it for a while. So it's not exactly a conversation, is it? It's not a rewarding engagement with that person. And all of these processes are asynchronous. Now, what about the telephone or the video conference, you may say? Well, you know, hands up if you've enjoyed a Zoom call in the last week. Anyone? No, not many. It's really not, it's not engaging, is it? It's not fun. It's glitchy. And there's something about even though it's just, because it's 2D, you are actually looking at someone's face, but it isn't having that kind of emotional reaction. You're not getting that relationship with the person that you do when you see them in person. Now, I'm not saying that the metaverse is going to immediately create immaculate 3D representations of your friends in front of you to have engaging conversations with, but it's moving us in that direction. And that kind of bringing people together is the same kind of experience that we get when we gather in large groups like today, or in an auditorium, or in a sports stadium. So, hopefully you should just see a slide in a second. We've been working on, I'm a slide behind, excuse me. We've been working on developing this kind of technology. One more, there we go. So why does this feel good? Actually coming together and being with people in a large environment, like a sports stadium, like in a pop concert, it feels fun. Think of the last time you went to see a concert playing, and the band came on, you were just waiting, and the whole audience was waiting for that moment they all came on board. And once they come on stage, everyone gets excited. Or when you went to a sports event and your team scored, and all of those hundreds of people around you, or thousands of people around you, react in the same way. It's an incredibly rewarding experience. Now, our company has been working on trying to replicate that experience in the metaverse. The example on the right is called ScavLab. It's a laboratory we built in a game called Scavengers. And I'm honestly going to say it was the best day at work I've ever had in my 30-year career, playing in ScavLab. And it sounds a bit trivial, and it sounds a bit crazy to say all I did was I ran around and I jumped around and I slid down mountains and I jumped over huge icy lakes, and I even killed one zombie. I think there were 7,000 and I only got one of them. But I was doing this with 4,000 people, 4,000 real people who I mostly didn't know, people from all over the world. And it was just really good fun because we were all together doing it together. It was a really engaging experience. So why? Why was that engaging? Well, because when you're in this kind of environment with all those people around you, it really feels good. Now, it's fun. Now, how does this relate to the military, you might say? Well, I mean, obviously, we want our people to have fun, but also, I would argue that this, because it's fun and enjoyable, is the sort of thing that people are going to end up doing in the metaverse. And as a result of that, that's where investment will likely go, and it's the sort of thing that will then develop into products that we need to work out how to use in the military. So where does that take us? Question then is, well, what are the technologies that are underlying this, and how can we use them for our own objectives? The biggest challenge that we have had to overcome in the metaverse has been that of speeding up computer games and making them run faster and making them run at more scale with greater numbers of people taking part. So when I was a teenager, I used to write computer games. I used to play them, and I'm afraid to say I had a rather solitary life, a very solitary life, because I wrote and played computer games on my own. And the only time I got to engage with my friends about this was at school, the day before or the day after. You know, we'd exchange code and we'd talk about what it was like to play the game. Now, Nadine mentioned her son. Now, my son plays computer games too. He's in his early 20s. And when he plays computer games, we have to shut the door because he's laughing so loud with his friends. You know, there was a real sense of community going on. they are having a great time. They are engaging in challenges together as a group. They're having meaningful shared experiences. They're building relationships. And I honestly did not understand this. I used to think that my son was wasting his time like I did and stuck up in some room on his own. He was actually out with his friends, but he was out in the metaverse of sorts. He wasn't just stuck up in his room on his own. Now, this kind of capability is great, but it's limited in its numbers. At the moment, we can maybe have 10 to 100 people engaging in a game. I mean, anyone here played Fortnite? Anyone? Yes? Okay. Fortnite is an awesome game, right? Absolutely awesome. And it has 100 players in the game. But you never see more than about 5 or 10 of them. And there's a reason for that, because the communications that's needed between each of the players basically increases, the overall amount of communication that's needed increases with the square of the number of players. It's an n squared minus n problem. So as you get to more than 100 players, basically the bandwidth that connects to your computer at home isn't insufficient to keep up. And you get latency problems, it just isn't any fun to play, and it will stop. Now we, in our company, are trying to create games that have thousands of players or tens of thousands of players. And the example I showed you earlier, Scav Lab, had 4,000 people, all and from various parts of the world, not all co-located, but all crammed into one small space in the virtual world that we created. And that meant every single one of them could, at times, see all the others. And that means you've now got 4,000 factorial interactions going on, and all of the communications necessary to make all of those people actually feel like they're living a real experience. Now, that way of working basically took time. It took us 10 years to develop the technology, to develop it. We worked on 4 different areas of technology. The first was the networking capability. We wanted to make sure that people would be able to communicate with each other fast enough across 10,000 different players at the same time. The second thing was rendering. If you think about it, your screen at home is rendered by your own computer, and you've got maybe 4,000 different people all moving around in front of you. And they're not just all moving together in a straight line, they're all moving in the way they would think. And in this game, lots of people were jumping around and they call it emoting, where they show a little light, and everyone's doing this. It's all great fun, but it all means there's a lot of effort that's needed computationally to render that, and it's changing minute by minute, or second by second. The third area is simulation. When you've got 4,000 people in this case, all interacting with each other, now in our case they were all controlled by humans, but once you start to you want to understand the physics of the interactions, you want to understand, in our case, as we apply this to the military context, the social interactions, the social implications of these interactions, then we needed to speed up the simulation. And we found ways of doing that. And then the final one was orchestration, because actually maintaining this kind of huge connected network over time is a complicated job in itself. It's a difficult thing to do, but we found ways of cracking all 4 of these. But the biggest sort of challenge and the biggest thing we overcame was compression. Because if you think about it, if you've got to pass information between 10,000 people instead of between 100 people over the same bandwidth, we're not talking big pipes here, we're talking about standard internet, then you've got to make an awful lot of compression to make that work. And that was where we applied lots of special machine learning to try and find out the best ways of reducing the amount of data that was required to transfer the same amount of information. So this is possible. This has been done. We're now looking at taking it to the next level, maybe an order of magnitude more or 2. We've also added audio. So this isn't just people looking at each other. They can now talk to each other. So they can talk to each other in a crowd. And that in itself generates all sorts of exciting things like spontaneous behavior. People actually broke out into song spontaneously in one part of the metaverse in one of our recent examples. So that development of technology is stuff that we've been doing in our company, but it's by no means everything. It sits alongside the development of content that we heard from Michael earlier, but also the development of interfaces. Now, I'm not a big fan of VR being seen as synonymous with the metaverse, but interfaces for users and interfaces for cyber physical systems, so a digital twin or an actual physical system itself, a building like this, for instance, to the metaverse, are being developed at the same time. And then we've got distributed ledger technology, which is vital to enable people to share information in an effective and secure way underneath it. And then that's in addition to the technologies that I've already talked about. So all of this is coming together at the same time. This is a bit like autonomous vehicles. Autonomous vehicles, there's not really one organization that built all the technology that can just make an autonomous vehicle. It's basically, it's the conflation of all these different things coming together at the same time. That's what's happening with the metaverse. There is no one metaverse company, whatever Mark Zuckerberg says about it. Actually there are hundreds, thousands of companies that collectively make up the ecosystem that's developing these technologies. So the question then I want to finish on is, well, what does this mean for us? What does it mean for the military? And the obvious thing to say is, well, we're at a training and simulation conference. What does it mean for training? And if I'm talking about basically enabling people to collaborate and to trust and to build trust and familiarity at scale, building trust and familiarity at scale, that matters in a collective training environment. Not all collective training needs huge amounts of scale, though. Some collective training is only needs a few people, or maybe has a relatively simple system that they need to learn on. But we've seen billions of dollars spent on the development of collective training systems that link large simulators over large pipelines, and this is a big and expensive and fragile way of building collective training. What the metaverse offers is an alternative. It offers an alternative, a very decentralized system with cloud computing. And just imagine a day when anyone can access their collective training system on their personal device. And they can do so anywhere. Imagine how much more adaptable that system would be than one where you have to go to a fixed location and sit in a fixed machine and you have to connect over fixed pipes to other fixed locations. Imagine if you can rapidly change the number of people or the types of systems that you've got. All of that, I think, could be enabled by the metaverse. Imagine, too, what it would be like if instead of a collective training system involving maybe 10 or 20 people, what if it became 100 people, or 1,000 people, or 10,000 people? Imagine how that would teach you new things. And it doesn't sound like it's very useful, but think about it. When do you see large numbers of systems and people coming together? A good example might be urban operations, where you need to understand the effect of lots of densely packed individual conflicts that are all going on that actually will all affect each other. Another example could be how to counter swarm attacks, where you have to represent each of the drones or each of the unmanned vehicles or weapons of some kind all at the same time, and they all interact with each other. That requires scale and density and complexity. And now imagine, what if you could connect your connective training system like that to that of all of your partners in other domains? And instead of just building brotherhood between the people in your section or the people in your unit, you now build brotherhood with people in other services or in other allied countries or in agencies that are partnered with you. And how about you actually involve the civilian population in some of your training systems? How about you involve some of your critics as well? Get them to experience at first hand just how difficult some of your situations are. So it's not actually so easy to throw rocks at you, which they like to do. All of these things are possible if we can increase the scale and density of these kind of simulations. And that means that we'll be able to collaborate and to learn basically how to trust and become more familiar with each other. So the last thing I'd like to leave you with is that's talking about collective training. But I have a background of 30 years doing research and development using modeling and simulation to help people make decisions. Now, I don't think that there's a clean line between decision support and training. I like to think that I was learning so I could help other people learn when I was doing decision support. Just like we want people to learn using simulations in a training system. It's all about using simulations to help us learn new things. Now, why can't we have a system that is basically transferable underpins a range of different functions across defense. Imagine if we could have the outputs of training simulations fed into people's plans for real operations. Maybe they could have 1,000 people crowdsourcing different plans for their next mission. Or the other way around, lessons from operations fed back almost in real time into training systems. Or people making decisions on policies, being able to use the same system to visualize the impact of those policies. None of these things is actually that far-fetched. And I think the metaverse can help bring us back to this kind of a way where we actually learn together, we collaborate across functions as well as across organizations. So, just to finish off, I talked earlier about the Letterman test. I'd be interested to come back in 22 years and see if this vision of the metaverse passes the Letterman test. I suspect that there'll be flaws in it, and I'd like to know what you think about it, but I also think you should try and figure out your vision for the metaverse. What do you think that it could do? How could it affect us, and how should we use it? How should we avoid using it, and how should we definitely use it? But just to summarize, my vision is that the metaverse is going to help us to come together, to collaborate, to make use of these kind of technologies that are being developed for the commercial world, because they work, they are fun, they're enjoyable, but that means they have some kind of social value, but it also means that they're great at embedding learning and training, and people want to use them. That's what makes something successful, when people want to use it. This is the kind of thing this technology I think will help us to collaborate, and it will help us gain trust and familiarity. Thank you very much.
Well, that's a great message on trust and familiarity at scale. So great job, Rob. I really appreciated that message. So we're getting ready to wrap it up here with our next speaker, Lieutenant Colonel Ryan Kenny. He's also got his PhD, and he's the commander of the 112th Signal Battalion for the United States Army's Special Operations Command. So Colonel Kenny, if you come up and help wrap this up and pull this together for us from a military perspective.
No slides, so I don't think I need the clicker.
Okay.
Hey, can everybody hear me okay? All right, great. I guess I'm bringing the military to the military metaverse today, right? I think we got a lot of context on tools and developments from the commercial sector, and I think all that stuff is absolutely relevant for what the military is trying to tap into. The first thing I want to do is just thank the organizers of the conference and this event for the invitation to talk up here today. I really appreciate it. I'm super excited to be here. This is kind of a pet passion for me inside my profession. Second thing I want to do is put out that disclaimer that the views and opinions expressed here are mine alone, don't represent necessarily my battalion, USASOC, SOCOM, et cetera. But I will try and bring my experience and reflections to this audience to hopefully provide some value and context where that partnership might be able to be further pursued. My background and where my interest started in this really comes from how I've grown up and served in the Army as a Signal Corps officer. So for folks that don't know, we do a lot of different types of jobs, from tactical deployments to enterprise solutions to training, doctrine, et cetera. I started out in the 82nd Airborne Division, deployed with them twice, served and commanded there. And during my second deployment, my battalion commander had come from JSOC and had worked for McChrystal, and he challenged me as a junior captain to deliver the same C2 command and control capabilities to his platoon leaders out on a tactical objective that he had inside his battalion command outpost. At that time, this is around 2007, 2008, I did what any good signal officer does. I hit Google to try and figure what technologies would enable that, because this was pre-5G LTE. You didn't have cell phones on the battlefield per se, smartphones. This was pre-mesh data networks. But we found a solution. We ended up being one of the first organizations to deliver that connectivity and pass classified information out to the edge to really that end user device. And this started my sort of genesis of trying to figure out what are the tools necessary at that tactical edge for decision makers, both trying to engage an adversary in very stressful environments, as well as those that are at the staff level that are ultimately going to have centralized resources and support that they may want to push forward, or authorities or permissions that only they can give in combat. Following that time, I transitioned to the special operations community, served there for a bit, and then headed up the Naval War College, where I took the time to focus my master's thesis on augmented and mediated reality technologies. So this was, again, about 2015, so a little bit dated in terms of what I was able to sort of bring to that question. But I was looking specifically at tactical and operational use cases and different vignettes and ways in which I thought the technology might be able to better support decision making. If you get into that arena, you immediately start to recognize that it's not simply placing people inside those environments that are going to make them better decision makers, it's how you provide them better decision support tools. And I think that was sort of a great comment in terms of the applicability of the metaverse and some of the tools inside that. If you start talking about personal assistance, you start thinking about AI, and you start thinking about how do you automate that? How do you take the benefits? And obviously 2015, 2016, you see this emergence and sort of resurgence, largely based on deep neural network advances, et cetera, on what those capabilities might be able to engender. That next year, I had a pretty unique opportunity again to work on a fellowship that was sponsored by the Chief of Naval Operations, their Strategic Studies group, and they always posed an annual question back in the day. And this question was, what does the future of human-machine teaming mean for the Navy? So I spent a year going out and talking to industry and really starting to get interested in the applications of AI, which culminated in me eventually throwing my name in the hat to go try and get a PhD at Carnegie Mellon, which I just survived, and then come back to the force to provide some perspective. So why did I unpack all that for you today? Because to me, the metaverse in the military isn't simply about training our soldiers to make them better. I think that use case is absolutely valid. But I think it's also about thinking about the future of humans interacting with these decision support tools in real operational environments. And I think that's where I might pivot the conversation a little bit from the emphasis of this conference and a lot of the NTs, is that we need to find a way to move that synthetic training environment into the real world, similar to what was discussed in the previous panel. I mean, some of those, hey, we saw this in training, how can we do it in the real world? When I think about the benefits of this digital ecosystem, it really begins with, one, the human that you are ultimately providing that decision support to, whether it's through an augmented reality device, VR, or simply a 2D panel. When I think about it as a leader, as battalion commander, I'm kind of focused on two different areas. One is, how can I do better deliberate practice, i.e. Anders Ericsson, sort of that 10,000 hours principle of guiding someone to better performance with the use of aid along the way. One of the things that was emphasized in that research is it's not just about doing those hours and sets and reps. It's about finding that point at which someone is struggling and you provide that expertise and that coaching in the moment. I think that is an absolutely great use case for these technologies and training. The second thing is I can quickly upskill folks. We've heard those stories. There's tons of that evidence on the trade floor. For me, what that means is, as a technician that manages a lot of IT engineers, how can I take a technician in the battlefield who may not have access to an expert sitting to their left or right and immediately guide their decision making if they have to troubleshoot a system, whether it be, as we've heard about, like with the F-35 or some more sophisticated systems, or in my case, a small SAT terminal, where I need to talk them through what wires to perhaps pull or check or check the signal flow for. The other side of that is thinking about the machine side. And this is, again, the other place in which I'd pivot from some of the conversations we've heard. I would argue the metaverse is not about the humans for the military. Or maybe it's part of the humans, but it's more about the machines as well. And that may be an uncomfortable conversation. But if you read what is going on in sort of the DoD emphasis for a third offset, it is really making humans more capable in employing unmanned systems and working with and teaming with unmanned systems. And so the operational employment of the military metaverse requires that ability to not only gain machine insights, but also then to guide and direct and respond to the scope of information that's flowing to those systems inside this environment in a way that humans can adequately reason through. When we think about machine learning, for this audience, I don't know your background, but I think there are three big things to sort of bucket all the different algorithms and tools into, just so you can register what the heck. We sprinkle AI out there. It's got to be great, right? At the end of the day, you have classifiers. Is it a dog? Is it a cat? Is it a dog? Is it a cat? Is it a cow? Right? So the military has classification problems. Is it a tank? Is it a car? Right? Very, very simple. We have prediction problems, which are, hey, if I know your height, can I guess your weight? Maybe. If I know your height and your gender, can I guess your weight? A little better if I know your height, your weight, and your age, can I guess your weight, right? So there's a variety of prediction problems. The military has the same thing. Are we gonna run out of fuel or not, right? Is there enough ammo in the warehouse? You know, who is at risk because, you know, physiologically they've been out in the field too long. They're at this point where their biometric feedback is telling us they're entering a danger zone. The third category, though, which I think is you know, maybe transformative for both society but also the DoD, is more of the generational AI. So it's not simply that helps you solve a problem and do a level of analysis that goes beyond human reasoning. It's something that allows you to truly generate a new idea or a concept. And obviously you look at what's going on with, you know, Microsoft's and OpenAI's GPT-3 efforts for natural language generation. If you look at the DALL-E efforts to generate 2D art, there's a number that are out right now, Meta with their video production. That's all generative stuff. Granted, it's for entertainment purposes, and we're seeing what they can do in terms of creating, you know, sort of something that's indistinguishable from what a human artist might be able to produce or a creator. But think about that in terms of a decision support tool. So if you're in the future asking a decision military support tool, what options best suit me in this setting, I think we anticipate in the DoD that you're gonna see better and better offerings from those decision support tools. So that's the third aspect of what this sort of AI capability combined with human potential, I think, means for us in thinking about the military metaverse. All right, let's go back and redefine the definition as we've all tried to do. So the military metaverse for me comes down to kind of three key aspects, and there are only about three that I care about for standardization. No offense, standards matter, but three that I think really matter for the DoD looking programmatically to interoperate and integrate a bunch of vendors. One is a common digital lattice. Can we all agree on that? So here's the digital lattice with the vector system. Maybe it's KML. I don't care. Whatever that digital lattice is, let's all agree to it, because then I can bring joint partners to that space, and we now have a common view of the world that's been a digitized version, a rendering of the real world, because I need that. I need that in conflict for decision making. I also need it for training for realism, right? The second thing is I need to be able to have a physics engine that we can all agree to as well. So I have a digital lattice and I got a physics engine, so things are gonna work the right way. At that point, how it gets rendered, how I bring other stuff in, doesn't matter as much to me, frankly. I think there's a third piece that is important and we can kind of get into, which was underemphasized, I think, in some of the previous sessions, and that is real world, real-time data. So for me, operationally, the military metaverse only matters if it can become a common operating picture for decision makers. And if I can zoom in from a strategic to an operational to a tactical level organization of understanding of who's in that battle space, both friendly, adversarial, coalition, joint, et cetera, and I can use that to then command and control, either because I'm directing and giving guidance or because I'm using automated decision support tools. That's where we want to be. That's where I think the DoD sees itself heading. But in order to do that, I need a digital lattice that we all agree on, common standards. I need some sort of physics engine that can predict and offer up consistent recommendations in terms of how things are going to react in that environment, right? And then I need to have the ability to bring in real data feeds to whatever that environment is so I can use it as a cop moving forward. So that's what I think it's about. In terms of your data formats in this and mine's in that, I can automate that. I can have APIs talk to each other. People in this environment probably get paid good bucks to be those integrators, right? It's painful, it's inefficient, but I can solve that problem through engineering. But without those other three pieces, the operationalized military metaverse doesn't mean much for me. I want to talk about today what we're actually doing inside ITSEC for some general back-end infrastructure development that I think will be an enabler for producing a military-type metaverse. You tell me if you agree with this or not, but I'll unpack it a little bit and hopefully it makes some sense. So when we talk about this integration problem, it really begins with talking about impact levels and levels of classification and what data I can share between organizations and people have privileges, et cetera, et cetera. Again, kind of like AI, you sprinkle zero trust on there, all those problems go away, you solve it. Just kidding, kind of. So what we've actually built out is an IL4 environment right now in the cloud. And inside that, using zero trust technologies, we're able to exquisitely manage who gets access to what data within what application. We have applications that are containerized. It's a Kubernetes environment, so I'm kind of getting in the weeds there for maybe some of the less technical folks. But the goodness of this is by allowing folks to enter into this environment in an IL4 arena, I can then solve a lot of problems through some cross-domain solutions that are, again, tied together through zero trust. This really helps out this population. You don't necessarily have to worry so much about, I can't get access to this classification or that classification. What matters most to us is getting data streams in and out of that environment. In terms of the end user device, it doesn't matter if it's a bring your own device or if it's a green box. We were out at Project Convergence. We participated over the last 2 years within my battalion, and ITSEC obviously. Just came from Pendleton and Irwin over the last month or so. And we've demonstrated this capability to senior DoD leaders, and it's at a maturity level where what I would tell you is we can bring the data in. We can pull in stuff from the battlefield, we can pull in open source data, we can buy commercial data, and we can populate it all inside this space. My message and my ask for the community here is we need to find better use cases for the data. And that's, to me, part of a data engineering problem, but it's also a requirements problem for thinking about better ways to say, this is the foundation within which the military metaverse could begin to be populated. Because it doesn't take much. We have PLI data inside that. It doesn't take much to render that on whatever geospatial reference you want to use to command and control forces, or a 2D dashboard you want to use to manage an application or some sort of system out there. The thing I mentioned there in terms of data engineering I think is pretty critical. This is maybe my second ask of industry is we're trying to measure and assess what's the appropriate level of compute in what stage and what environment for what headquarters. What do I mean by that? If I want to render these environments in real time and simulated, you're fully immersed, it takes a lot of compute, right? And if I'm in an environment where I don't have access to huge transport, I'm in a tactical austere headquarters, for example, I'm obviously going to have to think through what's appropriate and where I want to host not only these cloud services, but things that are being populated inside that space. This is kind of a wickedly hard engineering problem in general because it begins with understanding the infrastructure we have, but it also extends out to people that are developing the apps, either on an unmanned sensor or on a soldier walking on the battlefield or a jet, thinking about the problem of how much data do I need to pipe off the device, at what regularity, and where all does it need to go. I don't think the DoD has solved that. We're working hard to sort of guide and steer it, but I think that's a huge growth opportunity for those out there interested in solving those problems, maybe through other commercial applications where you're trying to say, hey, I have thousands of end users who are trying to all play the same game. I have thousands of combatants that are all trying to play the same game, but they also have really bad internet connections, like even worse than what you have, right? The last things I will sort of wrap up with is, some of the takeaways for maybe it's asks, maybe it's ways in which the DoD would love to see some more collaboration and input. And that gets into this general idea of if we provide a free market for development, how do we incentivize the development of these algorithms as a service? How do we incentivize the development of metaverse apps as a service? What I would challenge you with is, I came back from that awesome experience in Afghanistan. We delivered, this mesh network for the first time. The Army had seen it. We had soldiers getting real live ISR feeds during combat, sending that data back over this system that had never existed before. And as soon as we stepped off the plane, everyone had an iPhone or an Android device. And they said, why am I carrying that green box? I've got everything I want in this smartphone, right? The realization of the DoD at that time was we'd invested so much in the app being in the green box, then that it was tough to pivot to apps on smartphones. And the DoD thought at that time, if you kind of recall, 15 years ago, we need our own app store, right? We need a DoD app store for DoD Blackberries, I think, at the time. I would argue that we should be thinking about that transition for these cloud environments, not only for cloud applications, and that's a lot of what's underneath the hood for delivering the metaverse, right? So if we can get to that engineering level, but also if you're someone that's trying to feed some sort of standardized metaverse environment for the DoD, I want you to not have to rebuild that space. I want you to simply know the standards, be able to say, hey, I've got a better digital twin for that tank than these guys. And let's let the free market solve that. right? Why am I going to go to a sole source? No offense, I might be get booed off stage here in a sec. Why would I go to a single contractor to figure that out versus saying, here's a free market for some folks to deliver algorithm as a service or app as a service and be able to populate it in that, or maybe not as a service, but necessarily be able to sell that to the DoD inside that space and not necessarily not get access simply because you're not partnered with the primary prime. I think that's important in terms of trying to drive innovation moving forward to enable these type of capabilities. Okay, so shameless plug. I have to depart for the airport right after this. So if you want to follow up or you have a question, you can reach me on LinkedIn. I would challenge this community to force the DoD to make Project Convergence 24, which is in the spring of 24, by the way. They're going to skip next year. I would make it all about the metaverse because all the data's there, all the integration's there. We can target there. What's not there is this metaverse common operating picture by which different organizations, coalitions can come together and make those decisions. And that will take a lot of data engineering and effort to get to that point, but I think that's what is missing for the DoD today. So thank you very much. I appreciate your time.
All right, that was fantastic. Thank you for giving us that great military perspective about the military metaverse and challenging us for where we can go and what we should consider. Hey, we got some time left. What I'd like to do is invite our speakers up to the stage. And we got about 13 minutes for some Q&A, and Miss Juliana Sly has a microphone. So if you'd like to ask a question of the group, we can't see you right now, but she'll hand you the microphone. And
Start the cocktail hour early too. I'm just saying.
there you get one for the road.
I like that.
Not me. There's one over here.
Great. Thanks for an excellent talk, or talks, I should say. Does the panel think the metaverse will look more like a social network or the dark web?
Can I answer the military side and then transition it on? Since this is a military metaverse session, I'll just lead with that and save the sort of commercial opinions to my colleagues here. I don't think that's going to be the case, obviously, in a DoD environment. It leads to a couple points that maybe I left out of the talk, which are some of the risks of the metaverse and whether it's cybersecurity, whether it's sort of the objective truth that's being modeled, like how do we know that, how do we confirm that? Obviously, an adversary gets its hands in there. You could also argue people could go in there and do nefarious things or kind of, sort of hide in that space. I don't think that's necessarily a DoD problem, but maybe my partners think that on the commercial side, it could pose a problem.
I'll have a go. I mean, I think basically it depends on how it's governed, obviously, is an answer to that. We don't have strong views on that, but I do think that there is a demand, there is a need really for some kind of new way of governing this kind of thing. It needs to be allowed to grow like the internet grew organically, but it can't be allowed. It's going to be so intrusive into people's lives. I don't think it can be allowed to turn into the dark web. So the question is how you achieve that, especially as it will not be subject to national constraints and so on. So I would hope that it becomes more like a social network, but not controlled just by one company. That would be my aspiration.
Can I comment on this as well? Because this is obviously in the conversations in the Metaverse Standards Forum. They surveyed the entire community of the top 3 concerns and gaps areas. So the first top priority was 3D assets. That makes a lot of sense. And the third priority was the integration of real and virtual data. And the second one, they bundled privacy, security, safety, inclusion. So you can definitely see that topic bubbling up. What I look at is like there's not one metaverse. What we're trying to build here is the foundation for people to build metaverse environments. And some of them I think will be dark, and some of them will be social media, and some of them will be, like I said, the ultimate climate change app, and some of them military training, common operating picture. It could be anything. That's, I think, just like the internet. It could be anything, good, bad, and everything in between.
Okay. Any other questions?
Sure. Nadine knows I'm kind of like the metaverse heckler, but actually, I don't know if it's Lieutenant Colonel or Dr. Kenny. You hit upon a point that I love, which is that so many people focus on the experiential nature of 3D as being the party that everybody's going to hop around in with a device on their face. However, 3D, 4D, ND offers the highest accuracy digital representation of the real world. And therefore, we know that in the future, and in fact today already, that is being a fertile field for development of analysis prediction. So I'm 100% on the same page that the value of the metaverse in one big sphere, in the bigger sphere, is actually as an analytics engine and as a testing ground for AI. On the other side, I do appreciate that the speaker from Improbable, Rob, I think it was, that you said that it's not all about the VR, because it cannot be all about the VR. That's not an inclusive experience for humans, and I think there's a lot of negative to it. I'm glad you enjoy it. I do not personally enjoy it at all, even though I've been in 3D for 15 years. But thank you all. It was really, really interesting. I didn't really have a question in there, but just wanted to thank you specifically for pointing out something that I think the whole community needs to realize. The value is not in training people. It's in building up AI and analytics in which people will be interacting. So that's right.
I can't help but jump back on that, even though it wasn't a question. I felt kind of awkward saying it's not about the humans, right? We're at this training conference, and it's just a bad message to lead with that. But I think it's about supporting human decision makers in this large-scale combat environment, which the DoD thinks is probably the next potential threat, or it's the highest threat, right? It may not be the most probable, but because the risk is so great, we really want to get that right. And the assumptions going into the planning for military analysts is that there's a potential to be overwhelmed by cheap, low-cost, unmanned systems, and so how's the DoD going to combat that? If you follow any of the open source intel coming out of Ukraine, it's just really apparent that stuff is really proliferated the battlefield. So the second piece, which was mentioned numerous times, is sort of omnipresent sensing. And so the last time the DoD was really planning or thinking about these engagements, it was not in environments where neither our adversaries had such sophisticated and such scope of sensors to detect and target with, but also everything that's commercially available that could be scraped off a website and fed into a decision support tool. So I think that challenges the need for the requirement to sort of model and use those systems to come up with better playbooks for tactical and operational leaders, to your point. Yeah, thank you.
So I was in a session yesterday, and I saw that the military is actually pretty low on a scale of like 1 to 10 of how many, of like what sectors will adopt will adopt AR, VR, XR in general. Why do you think that is, and how do you think that relates to the adoption of the metaverse for the DoD?
You guys want me to lead with that? Okay.
Definitely you.
Yeah, a couple reasons. This is speculation, right? So someone with a PhD, right? You want to put your caveats out there. I think the first thing is, if you look at the IVAS and you look at sort of tactical employments of strapping stuff on soldiers, I think there's some controversy about the trade-offs that are taking place and sort of the human-computer interaction side of things. So when you conceptualize the use case for that, I think a lot of times we're defaulting to that sort of vision of what the military needs the technology for. And I'm talking AR, VR, that use case. However, if I said, hey, I'm a pilot with a heads-up display, no one would argue that that's needed, right? But it's the same thing, is it not? I mean, it's the same overlay of information, guiding decisions in tactical environments. So in part, it might be a little bit of an education campaign. In terms of the shift to data in the DoD, right now it's a campaign of learning. So data literacy, having a basic understanding of province stats, and then kind of move forward into machine learning and those discussions, and then further discussions of what's the right tool for the right problem you're trying to frame, and who does the analysis, and where do we get the data, et cetera. It's very complicated. It requires a level of sophistication that a young soldier may or may not have, and a generation of leaders have not been forced to kind of reckon with the same way that industry and the commercial sector has.
I'll take a stab at that too. So it's one of the things that next big thing is looking at. And for example, last year we did focus in on XR, as the primary technology that we focused on. This year we focused on the metaverse. And I think it gets to the nascent nature of the technology, and that's exactly why we are talking about it here. We're talking about these technologies that are just at that point to where there's enough out there understanding. We think there's promise behind it, but we got to understand it. We got to, have the conversations with the military and industry and academia to, figure out how do we realize the potential and the benefit of it. Where can it go? Where shouldn't it go? And so I think we're at that phase of these technologies. And when you look at, we'll go back to XR, there's a lot of research out there where they're saying, down the road, it's going to, exponentially take off. With the adoption of those technologies, we're starting to see those signs now as they realize, hey, it has great utility in this area, perhaps not so much in this area. And so we're in that phase right now with nascent technologies, and I think that we will tend to go through that. And I think even what we pick for next year with this committee will probably be similar. I'm sure we'll hear a similar comment, so, because that's what we want to do. We want to understand, we want to challenge perspectives and figure out how can we realize the power and the potential of these technologies for the benefit of our soldiers and sailors and guardians and airmen. So,
and also,
yeah, good.
Bob, I just repeat the point that it isn't all about XR. I mean, XR is really useful for many things, but the military has led the use of modeling and simulation for generations. The rest of the world has caught up now, and actually it's overtaken the military. And now it's the military's turn to catch up in terms of modeling and simulation expertise. And data analytics and so on. The military's been doing data analytics for generations again. Many of the aspects of the metaverse, the networking we talked about, the runtime, the ways in which compute is done, a lot of this came out of the military. So I think that the challenge is that the military has been an early adopter of many of these technologies, but it hasn't been able to scale them in some of the ways that maybe some of the civilian sectors have done. Maybe, I'll just postulate this, maybe that's because the military's job is a lot less standardized. It's a lot harder. I mean, we talked about Afghanistan. I built a model for Afghanistan, well, for Iraq, which wasn't available in time for Iraq. It was available for the Afghanistan war. It takes years sometimes to develop this thing. So you standardize something and then it goes out of date pretty quickly. And I would suspect that maybe we're not just slow to adopt things because we're slow. It's just that the world around us moves really, really fast here.
Can I comment on this? I'm not in the military, so I can't comment from the military, but this reminds me, I come from an aviation air traffic management, and it's not different, because at some point we saw the change when all of a sudden the pilots in the cockpit were saying, our passengers have better information. They have real-time weather in their iPhones or Androids, and they can get the flight stats or flight aware, and I'm stuck with some papers and some old interfaces, and that was the change and the modernization. So maybe sometimes it's not about the technology, it's about the why and the use case. So I appreciate the focus next time you need the use cases, because that will then drive it up if it's needed.
So her comments remind me of just another aspect too, which is a differentiator, and that is how we assume risk, right? So the Title 10, Title 50, whatever the authorities are for military, for police, et cetera, is ultimately society's willingness to say you have the authority to impart violence on others. But if you do that, you need to police that as a profession, and you need to do it in the right way, right? There's oversight, there's regulation, et cetera. And so commanders, even in conflict, right, there's a series of decisions in terms of rules of engagement and willingness to make that decision to take a life or to try and protect another service member. It is not taken lightly, and is obviously something that when you debate about outsourcing the decisions to an AI tool or willingness to adopt a technology before it's absolutely vetted, it's safe to whatever standard that needs to be. It's maybe a little different set of rules, probably similar to the healthcare industry and others that have to figure out how to underwrite that risk and assume it. So that may be another aspect why senior leaders in particular may remain skeptical or less willing to go all in on a technology till it's absolutely proven. Yeah.
All right, very good. We are unfortunately out of time, but most of us will be available for at the social to have further conversations with you all. We look forward to it. Hopefully we expanded your views and your perspective on the metaverse, and we're glad if we challenge some of them. And but anyways, we got the conversation going. Keep it going, and thank you very much for your attendance. And yep. And Miss Juliana Sly has, and I will help hand some out too, she has some of the tickets for the social in the back. Make sure you grab your ticket to go to the social, which is starting right now.